Logic is the science of the correctness or incorrectness of reasoning, or the study of the evaluation of arguments. Probably, the best-known application mathematical logic is in the area of higher mathematics and in the field of computer science, where the software development makes use of logic circuit design. It can also be used in law, philosophy, and other disciplines. There are so many ways we can use logic in everyday life. Even the act of convincing people of your own beliefs and arguments to be true is an application of logic. Yet, before we can get to determine the validity of arguments, let us first talk about propositions.
Let's now discuss lesson 1 in module 10. It's all about propositions. But first, let's define first these terms. The first one is propositional logic. When can we say that it is a propositional logic? It is only if it's a declarative sentence subject for affirmation or denial, or if it's a statement with truth value which is either true or false but not both. If you are given a sentence in which it is not declarative, say for example interrogative, exclamatory, or any other types of sentences, that sentence is not considered as propositional logic. If you are given a statement but then it's both true and false, or you cannot identify if it's true or false, it is also not a propositional logic. So take note that propositions are usually denoted by small letters. Here in our example, we have here the proposition P, I am beautiful. It may be read as P is the proposition I am beautiful. Now, let's determine whether each of the following statements is a proposition or not, or if it's a proposition, give its truth value. So in statement 1, it is proposition Q says rhombuses are squares. This is a proposition or not a proposition. Here, this is a proposition and its truth value is false because rhombuses are not all of the rhombuses are squares. Second statement, R is an equilateral triangle an isosceles triangle. Is it a proposition or not? Correct. This is not a proposition since R is not a declarative sentence. As what you've observed in the second statement, that is an interrogative sentence. A sentence which asks a question. In the third statement, we have here proposition or statement S. We have triangle ABC is a right triangle. So is this a proposition or not? Yes, it is not a proposition. Why do you say that it's not a proposition? Although it's a declarative sentence, but we cannot determine if it's true or false. Yes, so it is not a proposition. How about the fourth statement? T. My seatmate will get a perfect score in the logic exam. Is it a proposition or not? Yes, it is a proposition, but the truth value can only be determined after the exam, the logic exam. Last statement, 5. Statement U says that, welcome to the Philippines. Is it a proposition or not a proposition? Yes, correct. It is not a proposition because first and foremost, it is not a declarative sentence it is an exclamatory sentence. Yes. So we have here some qualitative categories of propositions. The first one is affirmative and the second one is negative. Let's first discuss on affirmative qualitative category of propositions. When we say affirmative propositions, these are the examples given. The first one, a quadrilateral has four sides. The Philippines is a member of the ASEAN, Association of Southeast Asian Nations. Whales are mammals. A circle has no sides. Humans are cousins of monkeys. So that are some examples of affirmative propositions. How about negative propositions? These are some examples. As what you can see, a right triangle has no obtuse angle. Are you sure? A right triangle has no obtuse angle? Okay, tomato is not a fruit. Parallel lines never intersect. Heroes are not immortals. Philippines is never an island. So, as what you observe in the sentences here, or in the statements here, although some are true, but these are considered as negative propositions. So let's now consider some qualitative categories of propositions. The first type of categorical proposition is universal proposition. So how is it described? It is described as the subject term taken in full extension. So example, all quadrilaterals are polygons. No parallel lines meet. Every integer is a real number. So that is universal propositions. How about the second, particular proposition? Here, the subject term is taken only in particular extension. Say for example, some algebraic expressions are polynomials. Some children are overweight. So, here, as what you observe, only some, not all. Only a particular part or particular number involved. The last is singular proposition. Here, the subject term denotes a single person or thing. So it talks about a single concept, a single thing, or a single person. Say for example, a prime number has only two factors. 2 is an even number. So we're talking of prime number and 2 as an even number. Next, we have this affirmative proposition. So as what you learned a while ago, we have affirmative proposition. Say for example, if we will consider universal proposition, let's say all x are y, and particular proposition, some x is y. So we will just talk of x, some of the x's. Some x is y. So that is all about particular proposition. But when we say universal, we will consider everything or all of them. Negative proposition. Say for example, all x is not y. Some x is not y in particular proposition. So the difference between universal and particular, in universal, you're considering everything or all of them. But in particular proposition, you will just select some of them or only, some of them. So here we can observe that A refers to universal affirmative propositions, affirmative, universal, affirmative propositions. But if we'll try to use not, that means we're talking of negative propositions. E refers to universal negative propositions. All X is not Y. I refers to particular affirmative propositions, and O here refers to particular negative propositions. So if you are talking of some and then you are pointing of not, that means you are talking of particular negative proposition. So let's try to identify if it's affirmative A, E, I, or O. What is A again? Yes, universal affirmative. How about E? Yes, E is universal negative. I is particular affirmative, and O is particular negative. So based from this statement, the first statement, there are snakes in every forest. There are snakes in every forest. So what classification is that? Is it A, E, I, or O? So let's discuss it one by one. The statement is clearly affirmative, and the word every suggests universal usage. So universal affirmative. Hence the statement is a proposition. How about the second statement? Some crocodiles are found in the city. Some. So you are talking of particular, are found in the city. So the statement is still affirmative, and you are talking of some, so it's particular. Particular affirmative proposition, that is I proposition. Yes. Last statement. Not all lamb is tame. How will we consider this? As what you can observe, we are using not. So it's very clear that it is already a negative proposition. But is it affirmative or universal? So here, the statement is negative. The word not also suggests a particular usage. Hence, the statement is an O proposition. So, not all, meaning you are just choosing some. No? Particular negative. Particular negative, that is O proposition. How about statement 4? Children are never as free as a bird. Children are never as free as a bird. So how are you going to consider that one? From the word never, it is obvious that the statement is negative. The word children suggests a universal usage. So this is universal negative proposition, or this statement is an E proposition. Last statement. Every odd number multiplied by 2 is an even number. Every odd number multiplied by 2 is an even number. So every odd number, since we're considering every odd number, so it means that we are considering the universal. Okay? Universal. However, this statement is clearly affirmative. So, this is considered as universal affirmative proposition, or that is simply an A proposition. So, that ends our first lesson in Module 10.